Hi, my name is John Coder, and I'm a math consultant with Faith Christian Academy in Arvada, Colorado. We're going to take a look at whether a constant can be a coefficient and a factor. To determine whether this is true, I wrote an example of a function f of x equals 30x squared plus 60x plus 15. To determine whether or not a number is a coefficient is a number multiplied by a variable. For example, the first term is 30 times x squared. 30 is followed by a variable. In fact, it's multiplied by it. So therefore, 30 is a coefficient. The second term is 60 times x. So therefore, 60 is a coefficient. And the last term is just 15. Well, since there's no variable there, it must be a constant. In fact, a constant is a number that does not change depending on what the variable is. For example, if I plug in the value of 0 in for x, and I substitute 0 in for x all the way through, this value would change, this value would change, and this value would not change. It's a constant. If I plug in 2 for x, this value changes, this value changes, but this value remains 15. So therefore, 15 itself cannot be a coefficient, but can it be a factor? In order to determine that, let's factor 15 out of this trinomial. We can factor 15 out because 15 goes into each of these coefficients, and 15 is a factor of itself. In fact, the number 15 has factors 1, 3, 5, and 15. So if I factor out a 15, 15 times what equals 30? Well, that would be 2. 15 times 2 is 30. And we have the x squared, which cannot be factored by 15. Next, 15 times what equals 60? Well, 15 times 4 is 60. And then finally, 15 times what equals 15? Well, that would be 1. So therefore, 15 constant can be a factor. However, it cannot be a coefficient because it does not establish the definition of a coefficient. My name is John Coder, and I'm a math consultant with Faith Christian Academy in Arvada, Colorado. And we just determined that a constant cannot be a coefficient and a factor. Thanks for watching.